Hello students, this is Mr. Estrada. The next lesson that we're going to learn is add and subtract polynomials. And before I begin, there are some vocabulary words that you need to jot down, and all these notes you need to copy down. And at the end of the video, I'm going to put some practice problems for you to do in your notebook, and then it's going to be in the hub that's going to be attached to this lesson. So the first vocabulary word that we're going to learn is a monomial. And a monomial is a variable, number, or a combination of variables, numbers, or exponents. And these are some examples that I have right here. So 2x, 4, y squared, 2xy squared. These are all monomials. Okay? And along with these monomials, we will have a vocabulary word in which you need to know. It is called a degree. And a degree is considered to be the highest exponent within a monomial. Okay, so the highest exponent in a monomial or a polynomial. Okay. So if we look at here, we're going to define the exponents for each of these monomials. So the first one here, I have 2x. Now, x is my variable. Now, the exponents for x is imaginary 1. In this case, the degree of this monomial is going to be 1. The next one is 4. Now, since we have no variable there, we can't say that there's an exponent. So in this case, since I have no variables for 4, the degree is 0. Y squared. Well, or y to the second power. The 2 is my exponent here, or my power, and 2 here is the highest degree. So the degree is 2. Now, let's say you have a combination of variables with different exponents. Well, this monomial here, the exponent of this is 1, and the exponent of this is 2. But since you have a combination of variables, the rule is that you're going to add these together. So 1 plus 2 is 3. Now we are going to also define degrees of polynomials. And polynomials is more than one monomial. So let me write that down. A polynomial is more than one monomial. So if you have more than one monomial or a combination of monomials, then that is a polynomial. Now, what we're going to also learn from this is a polynomial has to be, in order to add or subtract, you need to put this in standard form. Now, what do you mean about standard form? Well, the standard form of a polynomial is where you order the monomials with the highest degree first to the lowest degree last. So the standard form of a polynomial is to order the monomials from the highest degree first to the lowest degree last. Here's an example. If I have x squared plus 3x to the third power plus 2x to the 4 plus x plus 1. Well, I notice here that the exponents, or the degrees of each of these, this is in the second, so this is a degree of 2. This exponent here is 3, so the degree is 3. The exponent of this is 4, so the degree is 4. The exponent of this is an imaginary 1, so the degree is 1. And then this degree here is 0 because it doesn't have a variable. So if you look at this, if I just order it based on exponents, the first monomial will go first is 2x to the 4th. And I'm just putting these in order. The next one will be the third degree, so 3x to the third power. The next one will be x squared. The next one will be x, and then 1. So as you look at here, the exponent is decreasing from left to right. Now, let's say you are adding polynomials. Here's an example. So if we're adding them, here's 1. 3x squared plus 4x plus 3 plus x plus 2x squared plus 1. And I'm going to put this in parentheses because these are polynomials. So in order to do this, you need to put this in standard form. The first polynomial here is in standard form because the degrees decrease from left to right. The second polynomial that I'm adding to the first one is not, because they are not in order. The degrees are not in order, so I have to put them in order. So the first one is, I know my second term here is in a degree of 2. So that means I'll have 2x squared. Then the next one will be x. And then the other one will be plus 1. And I just rewrite the first one. Now there's a number of ways you can do this. You can add the like terms together. So you can add 3x squared with the 2x squared. You can put them together. Or there's another way you can do this. I would normally line them up like what you do in elementary school. When you're adding numbers together, you stack them up. So I will do the same thing. So 3x squared plus 4x plus 3. And I'm going to add that to this. 2x squared plus x plus 1. Now all I have to do is to add the coefficients, that means the number says next to the variable, and keep the variable as is. And I'm not adding the exponents. I'm not, because these have to be like terms. I'm adding like terms together. So 3 plus 2 is 5, x squared, plus, now here if I just have x, this is an imaginary 1. So this is 4x plus 1x, that's 5x, and 3 plus 1 is 4. Now, I said before, the degree of this polynomial. The degree of this polynomial will be the highest exponent of this polynomial. And in this case, the degree of this polynomial I had to squeeze in a little bit here. The degree of this polynomial is 2. So all you have to do is put this in standard form, add them up, add the coefficients, but keep the variables the same. Okay, so let's look at another one. Example 2. (10x to the third power plus 10x to the fifth power plus 4, and I'm going to add that to x squared plus 5x to the 4 plus x plus 1. Now, as you can tell, there are 3 terms here, 3 of them, and these are 4 terms here. No matter what, you have to put both of these in standard form. So if you look at the first one, my highest degree of this polynomial is 5. But I have 3 terms here. I have a 5, but I don't have the exponent of 4 anywhere. I don't have an exponent of 2, and I don't have an x. So how would you do the ones that are not there? You just leave gaps in between. So if you look at here for the first one, and I'll write this out, 10x to the 5th power will go first. I don't have anything to the 4th power, so I can write this down, 0x to the 4th power. Now 10x to the 3rd power, I can write that down because I have that. I don't have anything here to the x squared, so I can put 0x squared. I don't have an x, so I can just plus 0x. But I do have a 4, so plus 4. Now you can put it 0x to whatever power it is, if they're not there, or you can just leave it blank. Just have to put a little space in between the 2 terms in which you have there. Now I'll do the same thing with the second one. The highest exponent that I have here is to the 4th power, and I'm going to put that underneath where it is, where you have x to the 4th power of the first one. So 5x to the 4th will go first. I don't have anything to the 3rd power. I don't have anything in the 5th power, but I do have something on the 2nd power. So it'll be x squared. Now I have x, so I'm going to add that and stack that up. Put it underneath the 0x, and then plus 1. Now this is an extremely long polynomial, and you're going to add these up. Now anything is a blank that is considered 0, but you're still going to add with the 10x to the 5th power. That's going to drop down anyway. So 10x to the 5th power it is. 0 plus 5 is 5, and I keep the x to the 4th power. Then 10x to the 3rd plus 0 is 10x to the 3rd. Then 0x squared plus x squared. I know I have, this is an imaginary 1, so this would be 1x squared. 0x plus x, that's the same thing as imaginary 1x, and then 4 plus 1 is 5. Whew, that's a lot. So what is the degree of this polynomial? Well, the highest exponent in this case is 5. So the degree is 5 for this polynomial. So that's addition. Now here's an example problem that you need to look at. I'm going to put this underneath. Find the perimeter. I'm given an isosceles triangle. And an isosceles triangle, if you don't remember that from middle school, is a triangle in which it has 2 legs in which have the same size. Same length, I mean. So if you look at here, the 2 lengths each have a length of x squared plus x plus 6. And then I have the base here is x plus 5 in inches. So how would you find the perimeter? Same thing like anything when you're adding polynomials, is you stack up, you line up the like terms. So there's different ways you can do this. Now since I have 2 of these, I can take these and multiply by 2. So 2 times x squared plus x plus 6, close parentheses, plus, then I put in parentheses, x plus 5. Now, is it necessary to put parentheses? Yes. And the reason being is for this problem, I'm putting parentheses because I have 2 of these same lengths. So that's why I put the 2. And I have x plus 5. Usually it's to be in the same size you would put parentheses, but it's not necessary. Now, since I have 2 of these x squared plus x plus 6, this looks like a distributive property. So I can distribute the 2 with every term that's inside. So 2 times x squared is 2x squared. 2 times x is plus 2x. 2 times 6 is 12. Now the x plus 5, now I just have to put it where it's supposed to be for like terms. X goes underneath with x. And 5 goes underneath with 12. If I add these up, 2x squared plus 0 2x squared, 2x plus x, but that's also the same thing as 1x, plus 3x, then 12 plus 5 is 17. So 2x squared plus 3x plus 17 is the perimeter of this triangle in inches. So basically same concept, except we're dealing with geometric shapes. Now you can do this separately when you add, if you just add each one separately, you can still get the same answer. All right, now going back to this, and we're going to do something with subtraction. Okay, so we're going to subtract polynomials. So in a nutshell, you're just combining like terms. This, if you can remember, this is what we did in the beginning of the school year. And so this is like a very good review for you to understand what like terms are. So subtract polynomials. I'm going to use the same example that I did for example 1. Example 3. So I have 3x squared plus 4x plus 3. And usually with polynomials, you need to put the parentheses. Minus x plus 2x squared plus 1. So if you look at here, I have this polynomial minus this polynomial. Well, if I don't have a number here, you're taking away this from this. But how can you do this as an operation? If I can imagine here is the 1 here of the second set of parentheses, this negative 1 can serve as my number to distribute to everything that's inside of the second polynomial. Which means if I do that, all of these signs are going to change. 3x squared, I'm just rewriting this, 3x squared plus 4x plus 3. A negative 1 times x is a negative 1x. Negative 1 times 2x squared is a negative 2x squared. Negative 1 times 1 is a negative 1. Now I combine like terms. If I combine like terms, you can stack them up. And here's another way I would do it. I would make some shapes around like terms. I'll look for my x squared. So 3x squared, I can box this, and I have another 3x squared. This is minus 2x squared. 3x squared minus 2x squared is a 1x squared. You don't necessarily have to put the 1. Now, 4x minus 1x, that is a positive 3x, and a 3 minus 1 is a positive 2. So in this case, 1x squared plus 3x plus 2 is my answer. Now another way you can do this is to stack them up. 3x squared is 2x squared, and then I have plus 4x minus 1x, then plus 3 minus 1, and you can do the same thing. 3x squared minus 2x squared is a 1x squared. 4x minus 1x is plus 3x. 3 minus 1 is a plus 2. And as you can tell, both of these answers are the same. Okay? So as you look, there's different ways in how you can do this. Different ways in how you can do this. So if you have any questions, just ask. And please do the example problems, the classwork problems that are in the hub that is in the same folder with this video. Okay?